Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the Schrodinger time independent wave equation. So at the end of this lecture, student will able to understand or you can describe the wave function, what is the wave function, and you can derive the Schrodinger time independent wave equation. So coming to the wave packet, suppose actually according to de Broglie hypothesis, electron describes the wave nature. Electron describes waves. Actually these waves are not simple waves, complicated group of waves. Means they describe between two fixed ends, the wave is propagating to, again it is coming back. This kind of waves it will describe. And again in the next region it will describe the to and fro motion of the waves. That means complicated group of stationary waves and also the propagating waves. That's why to explain this kind of waves and to derive the wave equation, ordinary wave equation is not at all suitable for this. So now that wave equation is actually the Schrodinger time independent and Schrodinger time dependent wave equations. Two equations are there. Now we are going to derive the Schrodinger time independent wave equation. Imagine this is the small region. In this one, electron is moving to and fro like this. A small region containing group of complicated stationary waves. This small region is called a wave packet. This is called wave packet. In this wave packet, electron can stay at any place. So to locate such kind of electrons, we have to take one coordinate system containing 4 coordinates. That means I am just taking psi of x, y, z, t. It is the wave function. This psi is representing the wave function. At any instant of time t, it is representing the position of the particle with respect to 3-dimensional coordinate axes x, y and z. So psi is the wave function. So it is having the 3 dimensions x, y and x, y, z and t also. Anyhow, now to derive this one, let us imagine or let us consider a particle of mass small m. It is moving with velocity small v. Actually, it is describing the group of de Broglie waves. The de Broglie wavelength is given by lambda is equal to h by mv. Here, instead of x, y, z, t, I am just representing this as psi of r comma t. This is the wave function and at any location r under time t. Actually, the general wave equation for any this kind of propagating wave, we can write this as d square psi by this. Actually you can write dou square psi by dou x square. You have to write in case of 1-dimensional system. In case of 3-dimensional system, you can take dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. We have to write like that. Anyhow, the simplest form dou square psi, it is equal to 1 by v square into dou square psi by dou t square. Just I am writing. This is the general wave equation I am just taking. The solution of that wave equation is given by psi of r comma t. In 1-dimensional system, you can take psi of x comma t. No problem. Psi naught into e power minus I omega t. You can take like that, where psi naught is representing the amplitude function, omega the angular velocity of the particle. This is the solution say. Now, coming to, I want to just take dou psi by dou t. I want to differentiate this one with respect to t. Dou psi by dou t. Take the first derivative, what do you get here? E power I omega t, e power minus I omega t means you will get minus I omega into e power minus I omega t. So same thing I am just writing minus I omega into psi naught of r or psi naught you can take, no problem, e power minus I omega t. And again take the second derivative for this one, differentiating this one again with respect to t, what we get? Dou square psi by dou t square is equal to minus minus will be cancelled, I square omega square psi naught e power minus I omega t. We get like that. or what is I square? I square is equal to minus 1, we know, that's why same thing is written here, minus 1 omega square psi naught of r or psi naught e power minus I omega t. Again this minus of omega square psi naught e power minus I omega t, already we have taken this as the solution of this Schrodinger means wave equation, that is psi naught e power minus I omega t. Same thing I am substituting here, I get this as dou square psi by dou t square is equal to minus omega square psi of r comma t. In the one dimensional system you can write this as psi of x comma t, or in the three dimensional system you can write psi of x, y, z, t. Okay. Now this is dou square psi by dou t square we got. Substitute the same thing in this equation. So what we get here? Actually observe the same thing, dou psi by dou t, psi of x comma t or r comma t psi naught e power minus I omega t we are getting. Now this dou square psi by dou t square I am substituting in the next one, what we get in this one? Minus omega square by v square into psi. Actually observe the same thing in the above equation, dou square psi by dou t square. This one is substituted in the above equation, we get dou square psi. Actually you can simply write, where psi is a function of r comma t, you can also write dou square psi by dou x square in case of one dimensional system is equal to minus v square omega square by v square into psi we get. Or what is actually omega? Omega angular frequency, that is nothing but 2 pi nu. Nu is equal to c by lambda or v by lambda, where v is the velocity of the particle. That's why substitute the same thing, you will get dou square psi is equal to minus 4 pi square by lambda square into psi we get. Okay, and this minus 4 pi square by lambda square is written in the LHS. So simply every time you observe dou square psi only mentioned there, or dou square psi by dou x square, or you can take in the three dimensional system, no problem. That's why dou square psi is equal to 4 pi square by lambda square into psi is equal to 0. This equation we are getting. What is lambda? Lambda is actually the de Broglie wavelength. What is the de Broglie wavelength formula? Lambda is equal to h by mv. Substitute the same thing in the above equation, where lambda is there in the denominator. That's why what do you get there? Dou square psi plus 4 pi square by lambda square means by h square, that m square v square will go to the numerator. Observe here. So we are getting this as dou square psi into plus 4 pi square m square v square by lambda into psi is equal to 0. Actually what is this? Okay, observe, if E is the total energy, V is the potential energy. What is E minus V? Nothing but the kinetic energy. Kinetic energy half mv square. From this one I just write mv square is equal to 2 into mv square is equal to 2 into E minus V, we can write, or multiply with m on both sides. What do you get? M square V square is equal to 2m into E minus V. So this m square V square you substitute there, automatically we get dou square psi is equal to 8 pi square m into E minus V by h square into psi is equal to 0. We get like this. Of course, you can also mention dou square psi by dou x square in case of one dimensional system. So this is the Schrodinger time independent wave equation in case of one dimensional system. Observe, in case of three dimensional system I want to write. So how do we write in the three dimensional system? We can write this as dou square psi by dou x square plus dou square psi by dou a square plus dou square psi by dou z square plus 2m by h square or h cross square. I will tell you this h cross square E minus V into psi is equal to 0. Actually this h cross, what is h cross in this one? H by 2 pi. Actually we got 8 pi square m by h square. It is actually written as 2m by h cross square. H cross square you write h square by 4 pi square. 4 pi square goes to numerator. Therefore, 8 pi square m into e minus v into psi is equal to 0. This is actually the Schrodinger time independent wave equation in the 3-dimensional system. In the 1-dimensional system, you can write like this, or else you want to write dou square psi by dou x square is equal to dou square psi by dou x square plus 2m by h cross square dou square psi by dou x square plus 2m by h cross square e minus v into psi is equal to 0. This is in the 1-dimensional form, this is in the 3-dimensional form. Actually, instead of writing this one in the lengthy form, you can also write the short form as del square psi plus 2m by h cross square e minus v into psi is equal to 0. What is this del actually? Del actually del operator. Del square is called Laplacian operator. Del is the vector of, in vector analysis, del is equal to I bar dou by dou x j bar dou by dou y plus k bar dou by dou z. So, I dou by dou x plus j dou by dou y plus k bar dou by dou z. Del dot del, let us write I bar dot I bar, it is equal to 1. I bar dot j bar 0 you will get. Cos 90 0. That's why del dot del is taken as del square. So, you will get this as dou square by dou x square plus dou square by dou y square plus dou square by dou z square we get. So, instead of writing this kind of lengthy form, you can write the shortest form like this. What is the Schrodinger wave equation in the 3-dimensional form? In the shortest form, del square psi plus 2m by h cross square e minus v into psi is equal to 0. How do we say this is the Schrodinger time independent wave equation? Actually, we are differentiating this one 2 times, means we are taking dou psi by dou t and also dou square psi by dou t square. 2 times we are differentiating. That's why finally from the wave function psi, time will be eliminated. That's why the final equation is said to be time independent wave equation. Dependent wave equation is also there. In the next article we shall see that one. So, this is the Schrodinger time independent wave equation in the 3-dimensional form, and this is in the 1-dimensional form. So, actually in this article, coming to the summary, what we have discussed is what is the wave function psi. Psi is a function of x, y, z, t. At any instant of time t, it is representing the wave function or the position function with respect to x, y, z axis. And using that one, so we have derived Schrodinger time independent wave equation also. Okay, thank you.